Hello and welcome to another episode of 2D top-down game tutorial in Unreal Engine 5, and today we will be talking about enemy movement, behavioral trees and how to chase the player. In the end the game will look like this. The enemy will be able to move and chase the player when the player is close to it. At first we have to create the flipbooks for the walk animation for the skeleton, as we did multiple times before. So go to the sprites folder in the characters folder, search for the walk sprites, and for the first one hit the sprite actions extract sprites. And as we did in the previous episodes, we have to set the sprite extract method to grid, change the cell width to 48 pixels, and we can change the naming template to skeleton walk and direction. And we can click the extract button and it will extract those sprites for the animation. We will do the exactly same thing for the other directions, so we can search for walk and this time do the same sprite extraction for the up animation. For the left and right directions we will search for the run string, because that's how the artist named the animations for the left and right, but we will use the very same process to extract the sprites from the images. I will use fast forward to not waste time here. So once we have sprites for all directions extracted, we can select the first 6 of them for the down animation and right click on them and choose the create flipbook. And we will name the flipbook FB skeleton walk down, as we did in the previous episode for other flipbooks. Then we will move this to the skeleton folder and we will repeat these steps for the other 3 directions too. I will again fast forward this repetitive process. Once we are done with the flipbooks, we should have 4 new flipbooks in the skeleton folder, and we can now open the animation source skeleton. Here we will click on the add new button and add new animation sequence, and we will name it walk. In this animation sequence we will again click on the multi-directional sequence, and for each direction we will select the proper walk direction. So for example, search for the walk skeleton, and for the up direction select the walk up animation. We will do the same for the other 3 animations, so I will again fast forward to get the results faster. Now we have to configure the animation blueprint for the skeleton, so the animation is played when the skeleton is walking. So let's open the animation blueprint skeleton, and there we will go to the animation graph and locomotion, and here we will add a new animation state. So right click on some empty space, add new animation state, and we will name this animation state as a walk. Then we have to connect this walk state to the idle state, and also from walk to idle, because we can switch between idle and walk. We already have a code for these state transitions in the top-down characters, so let's open the characters hero and animation blueprint hero, and we will copy and paste the code from that. So in the animation blueprint hero we can open the idle to walk transition and copy this code from the animation blueprint hero to animation blueprint skeleton to the idle to walk transition. And the code simply says that we want to switch to the walk animation when the speed is greater than 0. We will do the same for the walk to idle transition, so open it in the animation blueprint 0 and copy it to the animation blueprint skeleton to the walk to idle transition. Here the code says that we want to switch back to the idle when the speed is 0. Now for the walk state, we will again use the animation blueprint hero and the walk state there to copy the set directionality, so the animation points to the right direction. So paste it there and connect it to the output animation, and we will add the play walk action to replay the walk animation of the skeleton and connect it to the set directionality. So that's the end of the boring part, and now we will finally do something new in this episode. We will start working on the AI for the skeleton, so let's open the content folder and create a new folder there called AI. Let's open that AI folder and right click in the empty space and add new behavior tree. And we can call this behavior tree as BT_enemy. The behavior tree is a tree of tasks which are executed to control our skeleton or any other pawn. I will explain how exactly it works while working on the skeleton as an example. So as a first task, we want the skeleton to move around on the map. To do that, we can click on the new task, and here we will create a new folder called tasks, so we can group all the tasks together. And in this new tasks folder, we will create a new task called BT task move around. Unreal will now open this task, and we can create new code here. When the task is executed, its receive execute AI function is called, and we need to override it. So let's click on the override and choose that function. In this task, we want to move the skeleton to some other place close to the place where it currently is. So at first we need the current skeleton location, and the controlled pawn is actually pointing to our skeleton instance. So let's use its get actor location action to get the current location of the skeleton. From that location, we want to call the get random reachable point in radius action, and this action will generate other point which is close to the current point where the skeleton is staying. The only input we care about is the radius, and we can for beginning set it to 50. It basically says how far the new point will be from the current location. Next we will use the AI move to action to actually move the skeleton to this new location. So add the action there and connect it to the input event. Then we also have to connect the random location output to the destination and connect the controlled pawn to the pawn in the AI move to. The last action to add here is the finish execute, which is special return action for the receive execute AI, and we will call it from both on success and on fail. So now we have a task to move the skeleton around, and we have to use it in the behavior tree. So let's switch to the behavior tree enemy and draw a line from the root node and create new selector. The selector node allows us to switch between different sequences of tasks. We can, for example, have one sequence of tasks to move the character around and another one to chase the player and attack him. I will show you how to implement this later in this episode, but right now let's focus on the move around sequence. To add new sequence, we have to create new line from the selector and choose the sequence. And in this sequence of tasks, we can draw a new line from it and choose the BT task move around. We don't want the skeleton to move constantly in a loop. We want it to move and wait a bit. So we will add the wait action and configure the wait time to 1 second and the random deviation to half second. I will now explain how it works. When the game starts, the root node will be active. The execution will go down to the selector, and the selector will select one of the sequences. We just have single sequence, so it will select this one. In the sequence, it will start executing each task from left to right. So the first one will be move around. And once the move around is finished, it will execute the wait. And then it will continue back to the move around and so on. The behavior tree itself is not enough. We have to somehow define that the skeleton should follow this behavior tree. And we will do that by using the AI controller. So in the AI folder, create new blueprint class and search for the AI controller. Choose it from the menu, click the select, and we can name the AI controller as AI_enemy. Open that AI controller and go to the event graph, and from the event begin play, create a new action called run behavior tree. In this action, we will choose the BT enemy as a BT asset. So now when we have the AI controller, we have to start using this AI controller in the BaseEnemy. So let's open our BaseEnemy blueprint, and there on the right side we will search for the AI controller and set the AI controller to the AI enemy. And now when we try running the game, we should see that the skeleton will start moving according to our behavioral tree. We immediately see that there are multiple issues, so let's start fixing them one by one. I would like the skeleton to move to bigger distance, so let's open the move around task and increase the radius from 50 to 150. Next we will have to fix the walk speed and also the skeleton rotation. And we have already done all of that in our hero character. So let's open the top-down blueprints and top-down character, and we will basically configure the skeleton or the base enemy according to the top-down character. So we will know the values we use in the top-down character and configure the same in the base enemy. We will change the max walk speed to 150 and also the min analog walk speed to 150. We are doing that to make the movement a little bit slower. Then change the max acceleration to 20,000 and the braking friction factor to 50,000. These changes are done to start and stop the movement immediately. Next we will choose the BaseEnemy class on the left menu, and in the right menu we will search for the rotate. We will search for the use controller rotation yaw and uncheck it. This will fix the character rotation. Now we can start the game and we can see that the skeleton movement is much better. The issue is that when we kill the skeleton, it still keeps moving. To fix that, we have to stop all the movement in the handle that function. So let's open it in the BaseEnemy. At first we will stop the AI controller, so let's get the AI controller action And this action has one input, which is the controlled actor, and this is self. So let's get the reference to self and connect it to the controlled actor. Then we can use the return value and call the getBrain component. And from the getBrain component, we will call the stop logic action and connect it to the jump to the node. Then we also have to stop any movement which is currently in progress. So to do that, we have to get the character movement and call its stop movement immediately action. We can now try running the game to verify that the code works correctly. So let's run it and let's try to kill the skeleton. And after this fight, we can see that the skeleton is not moving anymore when dead. However, the issue is that we cannot step onto the skeleton. We therefore have to change the code to make it non-blocking. So let's go back to the handle that function, and there we will get the capsule component. And from the capsule component, we will call the set collision response to channel action. We want to ignore any collisions with pawns, so for a channel, we will choose the pawn and we will keep the new response to ignore. We have to call this action from the stop movement immediately, and that way we have configured the skeleton to ignore the collision with our main hero when dead. We can test it out, and if we kill the skeleton, we can step on it as expected. We can also spend some time now to configure the speed of the skeleton because I don't like how fast it is. And to do that, we can simply open the BaseEnemy and search for the character movement, and there we will search for the character movement walking. And there you have to change the max walk speed and also min analog walk speed. I'm changing it to 100 here, but in the end I found out that the number 75 is the best. I have to say I like the new speed much more. So the last thing we will do today is adding the chase function. When we get closer to the enemy, it will start following us. To do that, we have to go back to the behavioral tree, so let's open the AI and BaseEnemy. At first, we will rename our sequence to move around, because that's the sequence where we have the move around tasks. And then we will create new decorator from the Decorator blueprint base. You can imagine decorator as a condition which will allow us to switch between multiple different sequences. Right now we just have single sequence, but soon we will add the attack sequence, and we want to switch between these two sequences depending on the position of the main player. If the player is close to the skeleton, we want the attack, and if it's not close to the skeleton, we will just move around. So let's continue with the decorator. We will add new folder and call it decorators to group the decorators together. And in this folder we will create new decorator called Decorator in attack distance. In this decorator, we just want to check if the player character is close to the skeleton or not. We will do that in the override perform condition check AI because that's the function executed by the behavior tree. It's very similar to behavior task, but it has the boolean return value in the return node. We will start by getting the actor location of the controlled pawn, which is our skeleton. We want to compute the distance between this actor location and the player pawn, so get the player pawn as the next action. We will use the get actor location from the get player pawn to get the location of the player pawn. And with these two locations, we can simply get one and call its distance action. Then we have to connect the second location to the distance action, and we can regroup all the actions so they look nice. Now we know the distance between the player and skeleton, and we just have to compare it to some threshold to trigger the attack. For that, we will use the less equal action, and as a threshold, we will set the number 50. As a last thing, we will connect the output of this condition to the return node return value, and we are done with this decorator. Now switch back to the BaseEnemy and we will use the decorator there. We will right click on the move around sequence and add decorator and to choose the Decorator in attack distance. This ensures that the sequence is executed only when we are in the attack distance. But that's actually not what we want to do. We want to execute this sequence only if we are not in the attack distance. So we have to click the inverse condition on the right menu. We also want to set the observer aborts to lower priority. Let me explain what this option does. We can add new sequence here under the selector, and we will call it attack because this will be our attack sequence for attack tasks. And now this attack sequence has lower priority than the move around sequence because it's on the right side from it. The aborts lower priority option in the move around sequence will ensure that if the player moves away from the skeleton while we are in the attack sequence will be aborted and we will move back to the move around sequence. Now we also have to add the decorator to our attack sequence, so right click on it, add the decorator and choose the in attack distance decorator. For this decorator, we will set the observer aborts to self because we just want to abort this particular sequence. Now we have to create new behavior tree task to move to the player. So click on the new task and search for the blueprint base and click on it. Here we will open the tasks folder and create new task called move to player. Click on the save button, and in this new task we have to override the receive execute AI function as we did before. Our goal here will be to find out the location of the player and move the skeleton to that location. To get the player location, we will just right click and search for the get player pawn action. Then we will add the AI move to action, and we will connect the controlled pawn to the pawn input value and also the return value of the get player pawn to the target actor. And this will ensure that the skeleton will move to the player. The last thing we have to do is add the finish execute action, click on the success checkbox and connect it to the on success and on fail of the AI move to. I also noticed that I forget to execute the AI move to from the event receive execute AI, so we have to connect the white line. Now we can go back to the BaseEnemy and add the move to player task to the attack sequence. And this should be all we have to do there. So if we try running the game now and we get close to the enemy should chase us as long as we are close to it. If we go further away, it will stop chasing us and it will go back to the move around action. If you open the BaseEnemy tree while playing the game, you can also see all of these actions nicely in the chart. Feel free to also play with the variables, so you can for example increase the 50 threshold to the 150, so the enemy attacks earlier. So that's all for this episode. I hope you liked it, and in the next one we will be working on the enemy attack. The skeleton will be able to attack us, and we will also show health bar for our hero. Please subscribe and see you next time. Bye!